Okay, fine. So let's proceed to the next topic. This is about wrapper classes. Okay, fine. We know the wrapper classes already. Yeah, which are the wrapper classes, right? Okay. So what are the wrapper classes? When corresponding to each of the primitive type, there is a class, right? So yes. So primitive type. Let me write both of them here. Okay. So we may have a primitive type called. Okay, the primitive types are the byte. Okay, and we have the corresponding wrapper class called byte. Short, we have the class called short. Int, there's a class called integer. Okay. Long, we have the class called long. Okay, float. Okay. For the char, yes, the name of the class is character. Okay, and we have the Boolean primitive type and the corresponding. So these are the corresponding wrapper classes. Okay. Okay, so let's look at what are the common things across all the wrapper classes. Okay. See, what is the purpose of a wrapper class? They have multiple purposes. Yes, what's the purpose of a wrapper class? Yes, one of them. Right. So, if you look at the purpose of the wrapper classes, one of them is about being able to use a primitive like an object. Okay, so we have these conversions from primitive to a object, fine, some reference type. Okay, so these are the equivalent. So for the primitive, these are the equivalent reference types. Okay, and we have a conversion from primitive to wrapper or wrapper to primitive. We call them as the boxing unboxing conversions. Okay, then we have the boxing and unboxing conversion. Right. This there is a lot of automatic conversion which happens here. Automatic conversion from primitive to a reference type, to the wrapper or wrapper to the primitive type. Okay, so okay, but this automatic conversion actually was available only from Java 5. So prior to Java 5, automatic conversion was not there, and of course, for these conversions, we do have methods in the wrapper classes. So wrapper classes have methods for doing the conversion. Okay. Another thing here, which I should mention here, is that all of these classes, okay, have a super class. Okay, so I'll put it like this. This has a super class called number. Okay, so we have this number as a super class for okay. So all of these have a number as a super class. Okay, when only these ones, except for the last two, when all others are extending from number. Okay, fine. Okay, other things common across all these wrapper classes, fine. So just this is, otherwise yes, those two, everyone anyway extends from the object class. Yeah. Okay. So from the instance point of view, see, another, we understand that classes have static members as well, right? We had a class called arrays. It's full of all static methods because it acts like a library. Okay, it becomes a library of functions. Okay, so here we have a dual purpose, right? One is yes, boxing unboxing, so the instance is getting used. Okay, whereas these also become a placeholder for a lot of functions, related to the primitive type. Okay, so anything related to the primitive type byte, lot of static methods available in these classes. So this is a placeholder for lot of static members. So we'll come across lot of static members. Okay, the only few non-static methods which are available in these classes. Okay, so instance method. Let's look at the instance methods. Okay, now instance method, as far as the subclasses of numbers are, number is concerned, right? So number is an abstract class. Okay, and has following methods. Yeah, which are the methods we have in the number class? So these are the abstract methods in the number class. Okay, fine. So method to return byte value. Okay, short to read. So they return the primitive type basically. And method names are just primitive type name and the value. Fine. Public int value. So 6 methods in all. Okay, fine. So that's what we have in the. So all of these anyway are abstract. Doesn't make a difference, but because the subclass will have to implement this. Okay, fine. So those subclasses of number, they have these common instance methods. Okay, another thing across all the wrapper classes. Okay, implement the comparable interface. Fine. So all wrapper classes implement the comparable interface, and therefore we know what method will be there. Fine. It will have that public int compare to method. Okay, and depending on the wrapper class, fine, whatever that wrapper class X is. Okay, I just put XXX. XXX is nothing but a wrapper class. Okay, fine. So in the class XXX happens to be some wrapper class, right? You will have this method called compare to. I think, yeah. Okay. Yeah, that's better. Okay. So we have the compare to method taking object of the same type. And it would be any, so appearing in the wrapper classes. So all of them have the compare to method. Right? Only thing here, what is surprising here is this again. The Boolean type, the primitive type Boolean, we don't have comparison operator, right? Yet the class Boolean implements comparable. Okay, this is still implementing the comparable interface, where what is the comparison? The comparison is the value true. Okay, true is greater than false. Okay, it's about comparison, so that's the way they have considered here. Okay, the implementation of compare to method is considering true to be greater, a wrapper object which has a value true to be greater than the wrapper object which has a value false. Okay, but anyway, and this comparable, making Boolean comparable, happened in Java 1.4. Okay, fine. So compare to method available for, fine, for numeric we understand. Fine, even char is a numeric as such, right? Fine, it's a char, it's a 16-bit unsigned value. Char is a 16-bit unsigned value. Okay, right? 2 bytes we understand, and so it's only that, yes, Boolean is something which could not have been compared, but yes, we have a comparison available for the Boolean type where they have considered like this. Anyway, so when we have this compare to, okay, fine. So compare to method for all the wrapper classes. Okay, related to the instance, if we have to look at, uh, the flow, the see number covers these 6 types, right? Number class. So what we see here is each class, each of the number classes, number subclasses, and which are the wrapper classes, right? So all of these 6 classes, fine, they have methods to return as a primitive type for any of the other 6. Okay, so even if I have a byte value, fine, I can ask it to give it as a float value. Fine, you may have a wrapper class object of byte, right? B equals something, right? Whatever it may be. But from B, so I've just taken an example of B. From B, you can use any of those 6 methods. So you can assign that value to a long also, long L equals B dot long value. That's the whole idea. Okay, so find conversion between the numeric types, all the number types, that's always available. I could have just taken B dot any of the, so B can, so any of the 6, from an object of any of the 6 classes, you can get it as a primitive value of the any other type. Okay, it will work similar to casting in the primitive type. Okay, fine. We understand with the primitive types the casting is available between these. Okay, so this is as good as doing a cast. Okay, fine. It may be upcasting, mixed casting, fine. No, mixed casting won't be there. Fine, upcasting or downcasting, whatever, right? So fine. So for this 6 classes, yes, this is what we have 6 common methods. Whereas for the class, the other 2 classes, the character and Boolean classes. Okay, let me just put for a character class. We would have a method, public method returns char. Name of the method is char value. So value methods are available in each of the each of those classes, character and even the Boolean. Yes. So Boolean also has a method similarly, and that method returns Boolean. So we have value methods in each of them. And only thing to note is the value method for the number subclasses is available for all 6 of them. Okay, right? So if I say boxing or if I say unboxing conversion, right? Yeah, what is the unboxing conversion? It's using the value method. Okay, see, for example, if I have a byte B equals, fine, whatever way we may have created, right? We can get it converted to equals B dot byte value. Okay, so everyone has that value, right? So similarly, if I have a character type, okay, fine, fine, you can extract the value as a, so this is nothing but your unboxing conversion. Okay, unboxing is from a wrapper converting to the primitive. Right? So the automatic unboxing conversion which is happening is using actually this method. When we say, oh, I want to cast, we can even do casting, right? That cast is allowed from Java 5, right? So if I do a cast for a C, yes, it's same as saying char value. Okay, fine. So casting to a, from wrapper to a primitive is nothing but involving the value method. Okay, fine. Let's look at the constructors here. Okay. Okay. If you look at the constructors, right, all classes except the character class have two constructors. Okay, right? There are two constructors. One takes primitive as a value, and which takes string as a parameter. Okay, so taking string as a parameter, the idea is, yes, we can convert a string to a primitive value. Okay, fine. See, example is like this. If you want to create an integer object, so I'll just give constructor from the integer class, but exactly similar thing for all the others. Okay, fine. I said except for the character class. Yeah, what is different about character class? Character class has only one constructor. Right? The string constructor is not there. Compared to others, right? The string constructor is not there. And so creating object, okay, so let me just take the integer example. It's like this: integer a equals new integer, and what I might use? I might use a something like this. Okay. Also, what is allowed for me is I can also create an integer even if I had a string. Okay. So strings will be converted to the primitive and it will be used. Okay. Fine. So creating a wrapper object is just simply about using the primitive value to create the object. Okay, string getting converted to a primitive and then getting used. That's the other option we have. Right? Okay. So one thing here is we have a lot of methods which involve the string conversion. Okay, of course the toString method has been overridden. Appropriate string conversion for primitives, right? We understand, right? If it's a primitive type, all primitive types can be converted to a string, right? Okay. So string conversion is available anyway. So toString, all methods of object class are anyway there. So toString method is available for the wrapper classes. Okay, fine. So instance related, yes, compared to method plus methods for string kind of, okay, method for I think, yeah, value methods, right? Yeah. Has only one constructor. All wrapper classes except the wrapper, right? It is except the character class. Yeah. And so if leave the character class, right? Character has only one. That's it, right? So that's what is mentioned here. Okay. So constructor is like this, right? Fine. Now coming to creation of a wrapper object. How wrapper objects are created. Okay. Wrapper objects would not be created using a constructor. We have a constructor available, the public constructor is there, but normally we would not use a wrapper, the constructor, to create a wrapper object. Okay, fine. What is available are static methods. Fine. Value of. Fine. So all the wrapper classes have a method called valueOf. Okay, and exactly like the constructor. Okay, so we have, for example, in the integer class, I'll just give example of the integer class. Okay, so in the integer class, we have a public static method which would return integer object. And ultimately, yes, we want an integer object. Method will be valueOf. Okay, parameter will be, oh, you can give the int. So just like the constructor, you give the int value, and that would create an object. Or we have the other constructor also. What's the other constructor? Instead of a primitive, you can give a string. Yes, you can give the string. Okay, so you may create an integer from the value or a string. Okay, let's consider that we have a string with us. Okay, so if we have a string like this, okay, we understand this can be converted to a primitive value. This can be converted to int, right? Okay, now I have a value which is available like this. What is this? FF? It's a hexadecimal string. Okay, now what about 4, 5? Yeah. Is this hexadecimal string? Yes or no? See, someone says, I'm giving this 4, 5 string. And we normally assume it's going to be a decimal. Right? But it could as well have been a hexadecimal. So a conversion to the primitive type from a string, and when we want to convert, we should know what is the base according to which it is to be done. Right? Even if someone gives a value 1, 0, right? If it is to be considered as binary, then the value is only 2. See, converting a string to a primitive requires one more information. What is the base, right? We call it as a radix here. It's known as radix. What is the radix value? Okay, right? So we have yet another way of creating a integer object, and that says, yes, you give me a string, but also mention the radix for it. If you don't give the radix, here the radix is considered as 10. Okay, fine. So if you are not mentioning the second parameter, so we have the valueOf method taking 2 parameters. Fine. First parameter, a string. Second parameter is the radix. Okay, so yes, considering that, so if I'm passing this value 1, 0 or FF, some string, I can say I want to use the radix of 16. I want to follow the radix of 16. In that case, yes, even 1, 0 is there, so it will be the value 16 basically. If you write 1, 0 as a string and say it is hexadecimal, then okay, the value becomes 16. Okay, right. So here, yeah, what is the possible value for radix? What are the possible values for radix? Yeah, radix can be, we can start with, we can't say radix is 1, we have to start with 2. Fine, up to how much? What's the maximum radix value? Someone can always say, I want to use the radix 3. If someone says the radix is 3, what are the characters available for use in the string? If it was radix was 2, that means binary, right? So it would be 0 and 1. If radix is 3, then 0, 1 and 2. Fine. If radix is 10, 0 to 9. And that's a common thing, right? Decimal system. If radix is, what can be the radix value? Radix is 12, then what are those? Going up to 11, that means 0 to 9, and then after 9 what will it be? A and B. Okay, it will use only these characters, 0 to 9 and A, B. Okay, so what's the maximum radix? You can use 0 to 9 and you may use A to Z full. Okay, so your maximum radix is 36. Yeah, so it goes from 2 to 36. The range for radix value can be from 2 to 36. Okay, so it's like what is your base which you would like to follow? So string is there. So here if there is a string like this, ff, and you're saying my radix is only 12, then that would result in exception. Okay, that would be an exception. ff, and you're saying, oh, radix is 12. Radix minimum 16 is needed for f to work. Okay, 16 or greater for a character like f. Right? So whatever string we are giving, it is scanning the characters whether they are valid for the current radix or not. Okay, it will be scanning this and saying, okay, accordingly it will be giving, right? It will so if it's not, if you have invalid character, yes, it will give a throw an exception, number format exception will be thrown. Clear on this? Okay, fine. So this is for creating a integer object, right? So similarly, this this overloading, see, we have this static value fine. This is, so these two kind of things, that's corresponding to the constructor. Okay, even the constructor, two constructors are there. Okay, so similar value of method available for all the wrapper classes, at least two value of methods will be there, right? Only for integer and long, the option of giving a radix is available. Right? Integer type and the long type, we have the value of method where a radix can be passed as a parameter. Otherwise, we understand the radix is going to be 10.
तो radix जो है वो 36 वैल्यू तक ही ले सकते हैं
2 to 36, yes.
मतलब उससे ज़्यादा 3 डिजिट का वैल्यू लिए तो नहीं जा सकता
No, not 3 digit. It's about radix value. See, radix is deciding if radix is 36, what is allowed?
No, radix is 444.
No, radix is the base. If the radix is 2, what characters will be allowed? Only 0 and 1 will be allowed in your string. The string, fine. See, your string can, it's a string like this, right? Can I give something like this and have a comma also in this and say, let me try to get it converted into a string, into an int? Can this be converted to int? No, right? So what is allowed? That's the whole point. If it is having, okay, let's say if it is having 2, 0, and I say, oh, let me use a radix of 2, is it valid? If you are saying radix is 2, then what we are indicating? We are indicating this string contains binary digits. 2 for binary digits. That means there are only two possible digits, 0 and 1.
That is not allowed up to 36.
Up to 36 only. Fine. Radix of 3, yes, then this is valid. Right? We have number and the base. Fine, what base? When we say hexadecimal, what does it mean? It means the radix is 16. Hexadecimal allows from 0 to 9 and A to F. There are total of 16 digits possible because we include 0 also. Okay, starting from 0 to 9, that will be the 10 of them. And then go from A to F. So that way we have radix of 16 which is valid. Fine, 16 makes it hexadecimal. Okay, so you are allowed to go, if someone can say, okay, I want to use a radix of 17, I also want to include G also. After F comes G. So if someone says radix is 17, that means yes, you have your numbers which are following a base of 17. Okay, so that way you can go by saying, okay, I have a base of 36, base 36. Okay, and it's not about how many digits can be there, it's not about that. Okay, here you may have any number of digits, right? It doesn't matter. Oh, this is more than 36, then also, oh, we can't have more than 36 anyway. If you are convert, see, one more point here is we convert to a primitive type, int type. Okay, what's the range for int? Okay, because there's another point here. What is the range for int? Okay, what is the range for int? It goes from minus 2 to the power of 31, 32 bits in all, one for the sign, right? And goes up to 2 to the power of 31 minus 1. Right? So the string which you pass should not exceed that. This will come out to be some 18-digit number. Okay, so if I'm using a parse, I'm using the valueOf method and I'm giving some 19-20 digits number. Okay, then it will fail. This is going to fail. Sorry, this is 10-digit number. Yeah, int is 10 digit. It's a long where it goes up to 18-digit number. Okay, fine. Long would be fine. Range for long would be minus 2 to the power of 63. Okay. When we understand these are the ranges, right?
I have 10 number digit.
10-digit number. Okay, but which one? That matters because yes, you may have a 10-digit number like this.
I have to convert radix.
Okay, you have the 10 digits and I'm assuming decimal here. Okay, so if you are having, see the 10 digits in decimal. If it is hexadecimal, how many? No, that is the radix. What is my range for int type? What's my range for int type? If it is binary, how many digits are allowed? How many binary digits for int value? Binary digits are bits. How many binary digits for int value? Okay, so yes, if you are assuming this to be decimal, okay, this is not a valid int. Fine. For int, you can't be having more than, you have to consider the range also, right, while doing a conversion. Otherwise, it will fail. Okay, you can't have out of bound. Fine. Okay, fine. I can quickly show this. Okay, sorry. Okay. Let's quickly look at this in J shell. Yes, we can use J shell here. Okay, and we want to use integer dot valueOf. Okay, so int a equals integer dot valueOf, and yeah, let's use a string. And what's a string we want to have? How many digits? Okay, a number of digits are there. I think more than 10 sufficient, right? Easily more than 10. Okay, so if I just say like this, number format exception from input string, this, see, there's no, all of them are decimal digits, yet it is failing. Fine. Whereas instead of integer, if I had taken it for a long type, this is about the range, okay? This is because of the range. Yeah, that's valid for me. Okay, whereas the same thing, if I make it now 18-digit number, okay, more than 18 digits, yeah, that's going to fail. Okay, fine. Let me also show you the use of radix here. Okay, so let's consider int type. No, we can't have two. Okay, they're easily more than 10. The size is more than 10, but I am saying the radix is 2. With the radix 2, there can be up to 32 because it's a in bits. That's a decimal value. Okay, this is to be considered as binary, and this becomes the decimal value for it. Instead of base 2, you might say, okay, let me use base 3. Yeah. Okay. And so the meaning of base is there, right? See, this can be, if I had the value as ff, okay, and I say this is 16 hexadecimal, yeah, you'll get 255. Yeah, so it's not only what characters it is made up of, right? The two checks. One is the characters have to be according to the radix. If you don't mention radix, radix is 10. Fine. As well, the range also has to be considered. Okay. Fine. So we find this is how integers can be converted. Okay. Let's come back here and let's check a few more things here. Okay. So fine, clear about the radix part. What is radix? Base. Fine. Okay, so how the string has to be, so whenever there is a string, yes, we'll have to also mention about the radix. Okay, fine. So fine, now the boxing and unboxing conversion. So when someone says boxing conversion, right, how boxing conversion is done? Converting a primitive to a wrapper. Okay, from primitive to wrapper. So if I'm saying integer, okay, x equals, and automatic conversion, if you want, I can just simply assign a value like this. Okay, this is basically, this is doing a auto boxing conversion. This is equivalent of saying integer x equal to integer, yeah, dot value of 75. Okay, fine. So when we write like this, the boxing conversion is happening automatically, but the conversion is just doing this. Okay, so wherever you are doing a boxing conversion, this is the boxing conversion. The boxing conversion does not use a constructor, and it's important to know that it does not use a constructor. Okay, now another aspect about the value of method. Now let's look at this value of method, a very important thing related to the numeric type especially. Okay, fine. We have, okay, one more point before I proceed further. We may even have a look at the Boolean class. Okay, the Boolean class has, it has also got those two constructors, and how the conversion will happen. Suppose someone says Boolean b equals Boolean dot value of, and suppose he's using a string, right? He's using a string and he says, okay, so that's going to turn out to be true. Fine, it will hold the value of true. Okay, what about someone doing another way? So if someone tries like this, okay, sorry, yeah, that's going to be true or false? This is going to be true. Okay, someone uses a string which looks like, correct, or someone uses a string which looks like, yes. What do you think? These will be converted to true or false? String conversion to a Boolean. Okay, let's look at the string conversion to Boolean. Okay, how does it get converted to Boolean? These two will be false. Anything other than true. Okay. True. Anything other than true is fine, false. Okay. And yes, when we say anything other than true, fine, any case, ignore case. And it's ignoring the case. So even if it's uppercase, that's fine for me. It's still true. Okay. You might have put upper, lower, mix, whatever way you may put. Yes. It has to be exactly 4 letters, TRUE, upper lowercase does not matter. Then it will be converted true or true. All other strings, if you are trying to convert them to a Boolean, will get converted to false. Okay, fine. Now something about the static methods. Okay, this is a static method, value of method is there. Another thing which is related to the some static members of the Boolean class. So Boolean class has two static variables. Okay, and which are those static variables? Their type is Boolean. So we have public static final. Okay. Name of the variable is, okay, and it has a Boolean value of true. It is nothing but some object created with the Boolean value of true. Okay, and same way there's another member called, oh, I didn't mention that. The type of the variable is Boolean. Sorry. So we have this Boolean object of the wrapper class, okay, which has the value for true and false. So two separate objects are there. Okay. Right. So two objects, static members, true and false. The type is wrapper class. Okay, they are available, and so they have the wrapper objects. Now, what do you think the value of method for Boolean is doing for us? Does it create a new object each time? See, your value which you pass is true or false. In the value of method, you are passing a true or false. Even if we are giving a string, it has an interpretation to get it converted to a true or a false. Okay, if you are giving true, it's returning this object, boolean.true. If you are saying false, it's returning the other object. More than two objects are not required. Yet you have the public constructor available. Okay. It's advisable not to use the constructor. Yeah, one very important thing here, I should have mentioned it right at the beginning. Fine. All wrapper classes fine, are final. Okay, no subclassing is allowed, and instances of wrapper classes are immutable. Okay, once an object is created, with so for example, this true is there, right? The object true is there. It's an object, right? It's referring to an object. So that object holds a value called Boolean, of type Boolean. Primitive Boolean is there inside the object, right? You do not have a way to change the value. If it's created as a true, it will remain as true only. You cannot change it to false. Fine. And that's the reason there's no point in creating more than two objects of the Boolean class. Okay. So if you use the value of method, do you think it is calling the constructor? No. It's using one of these two objects. Yeah. If you call constructor, it's a new object. Fine. Whereas you use the value of method, it's not creating a new object. It's not allocating a new object. Okay. Now let's come to this one, integer class. Okay. Let's look at the integer class again. We have integer a equals. Fine. If I just say 100, or let me use the value 1000. Okay. If you have 1000, yeah, what's happening? This is equivalent of saying integer a equals integer dot value of. Okay. It's not called the constructor. Okay. It has not called the constructor. Okay. So these two are equivalent, but anyway, now I want to use another object. Let me have a, so you may have used one of those two ways. Fine. Either of those two is fine. Okay. And I also want to use the value of method here. Okay. So it's like these two are equivalent and these two are also equivalent. Okay. Now the question is whether a double equals b is true or false. What do you think? It is true or false? False. Okay. This will turn out to be false, and suppose I make the change and make it 100. Instead of 1000, I'm making it 100. And in that case, this becomes true. Let's check it on JShell. Okay. Integer a equals, and we can see, okay, let me just assign directly 1000. Okay. Integer b equals 1000, a double equals b, that's false, right? And then let's use a equals 100, b equals 100. What's a double equals b? Oh, that's true. Right? You can see this. One thing is clear. In case of 1000, it has actually used a constructor internally. The value of method is using a constructor, but when the value was 100, it did not use a constructor. and gave us the same object. See, in case of Boolean, we have got two values, right? And therefore it was reusing the same value. See, if I do a similar thing with any two Boolean values, if I'm saying, right, value of, fine, it's going to always be equal. It's the same object being shared all the time. Now what we have is there is some kind of a caching which is done here for the number types. Okay, all of these byte, short, integer, long, not the float and the double type. Oh, for float and double, there's no caching. There's caching only for 0. In float and double, 0 is being cached, no other value. Okay, so the idea is if you are trying to use a parse and the parse, not parse method, sorry, the value of method to get an object, fine, it will see if it is available in the cache, it will use from the cache. I shouldn't say cache, basically it has created a set of objects. Okay, so there are the range which is available. Okay, values in the range minus 128 to 127. Okay, values are shared. I'll put it this way. I'll not say cache, values are shared. Clear? That's the whole point. And we should be aware of this. This is for the byte, short, integer, long. Okay, byte, short, integer, long.
इसका मतलब 170 से ज़्यादा वैल्यू आई तो हो जाएगा कैसे?
False. The value of will use the constructor. Fine. Value of is giving by using a constructor. If it is in this range, it has created these objects already. The objects in the range minus 128 to plus 127 have been created, whereas for character type, right, let's see, for character type, let's confirm for character type. I am not sure on the range. Okay, for character, values in the range, it's because it is an unsigned type, it is from 0 to, I'm not sure whether it is only up to 0 to 127, or it may be, I have to test between this, so choice between 0 to 127 or 0 to 255. Okay, it's fine, mostly it should be 0 to 127, that looks more logical, but maybe it is going up to 0 to 255. So let's try it out. Character C1 equals, and okay, we can use the value 100. Yeah, 127 anyway is cached, so let's go beyond one. Okay, 200. Okay, yeah. Okay, so 200, yes, it's unable to show that, that's fine. It doesn't matter to us. Okay, and C1 double equals C2, that's false. Whereas if it was 100, okay, that's going to be true. So it's 0 to 127. Okay, those are the ASCII characters basically. Fine. So for ASCII characters, yes, they are available in a shared mode. Fine. So those objects are pre-created basically. Internally, it has created those objects and managed them in the class. Fine. So yeah, it's up to this. Fine. So clear on these aspects now. Fine. So value of method is clear. Boxing, unboxing conversion which happens. One is using the value method, other is using the value of method. Boxing conversion is value of method. Okay, next. Okay, so this is more related to instance, the creation and the methods available on instance, right? Now, looking at the other static methods, like so common static members. Okay, there are some common static members across all the wrapper classes. Okay, so we have public static final. Okay, these will all be public static final. I'm talking about the variables here. Fine, initially, so all of them will have a variable called size. Okay, so what is the size? It would be the number of bits. Okay, the type is int here, sorry, the type would be int. Okay, number of bits. Okay, so it tells us the number of bits for the corresponding primitive type. Okay, same way we have the public static final int, and we have something called bytes. So number of bytes and required for the type. Okay, okay, another one is public static final, type is class, and this is called a type. So we have size, bytes, type, these are the static variables basically. For the primitive. Okay, fine. If someone see what I'll just mention here, if someone says integer dot type, okay, it is same as int dot class. Okay, it's a class object for the corresponding primitive type. Type is nothing but a class object for the corresponding primitive type. We understand class object exists for every data type. Okay, so int dot class is of type class. So integer dot type is same as int dot class. Okay, okay. Now something which is not for the Boolean but for all the other things. Okay, other than Boolean, we do have now public static final. Okay, I'll not so this depends, I should say other than Boolean. Okay, W www, let me put this, that would be considered World Wide Web. Okay, some type W is there. Okay, fine, then the type here is W. Okay, I should use the capital so that it's about the class and not the primitive type. Okay, no, it's actually about the primitive type, sorry. Okay, fine, that W is of type is the primitive type corresponding to the wrapper class W. Okay, fine, we have the variable called min underscore value equal to, and so for example if it was byte, min value will be minus 128. And same way, so min value, max value, two variables like this. Fine. So min value, max value is also available. Range for any primitive type you want to know, we have these variables, right? For example, you may like to consider, compare maybe is a greater than, is a equal to, or maybe fine, a is less than integer dot, or sometimes you want to make comparison and you want to find the minimum value, right? So you'll say, okay, let me start with int a equals integer dot, okay, and something like this. When you might like to use the what is the minimum value, assign it, and then maybe start working on this. So you have the full range from min value to max value. You may, because it's a 10-digit number, you won't remember what it is, right? So writing as a constant rather than that, you can just use the no use. Fine, we may not need to write a literal for this. Okay, so min value, max value, that can be used. Okay, fine. So this is for anything other than the Boolean. Boolean doesn't have min value, max value. Okay, so static fields here. Okay, there are some classes which have some special static fields. Okay, okay, for the float and the double class. Okay, because I'm just currently looking at the static variables here. Okay, so we have float and the double class having public static. Okay, okay, fine. Now for the float, I'm just mentioning it for the float. Okay, final float, the type is float, and name of the variable is you have the value positive infinity. Fine, same way, this is in the float class. Okay, what's the other one? And what's the third one? Okay, so this is available in float as well as in the double class. Okay, fine, the type will be accordingly changed. Right, this is in the float class, it's like this, and same thing for the double class. Okay, and I'm not repeating them again. Right. So these are special numbers which you can use. We even have methods now, some special methods for the, okay, now coming to the string, let's first look at the string conversion. Okay, methods for string conversion. To and from string, right? You may convert from string to the primitive or from primitive to the string. Okay, fine. Conversion from primitive to a string or a string to a primitive type. Let's see that. So first is conversion from string to primitive. This is more commonly used. Okay, when string to primitive, that conversion from, many times our input will be string type and then we would like to convert it into a primitive. Okay, so we have this static methods again. So it is now about public static final, not final, sorry, public static methods returns the primitive type p. Okay, I've just said p here, right? So it's a corresponding primitive type appearing in the corresponding wrapper class. Okay. Okay, so let's assume like this. So in the class W, okay, we have public static method returns p. Name of the method will be parse, and whatever that. Okay, what should I do for this? I'll just say ppp. Ppp is nothing but a primitive type. Okay, so parse ppp is the method which would take a string as a parameter. Okay, example would be integer class has the method. So integer class has, okay, for static returns int. Name of the method is parse int. Let me just keep a capital P here. Okay, and passing a string. Okay, fine. For the integral types, okay, for the integral types we have the methods. Okay, for integral type means integer, okay, byte, short, integer. Okay, we have this public overloading is done. Int the parse ppp method takes as parameter, okay, string s and int for the radix. Fine. We know the radix range is not 0, sorry, 2 to 36. Yeah. Okay, so parse int, parse long, parse double, they will be in the corresponding, but we can pass two parameters there, but not for the float and the double time. Okay, so we do have parse float, parse double, parse boolean. Okay, string conversion, converting from string to, we don't have the string conversion to char. String conversion to the char type, the character class does not have this, because how do I get we have the string class having a method called char act, because when we say string, it's made up of so many characters, and you're saying, oh, I want it to be converted to a char value. You can easily pick up the, if you are interested in the first character, pick up the char at 0. Okay, fine. So no string conversion to char. Okay, but any other thing, for other types you can convert from string to the primitive type using the parse methods. Okay, so these are the parse methods in each of the classes. Okay, for these four we have the option of specifying radix also. Okay, so default radix is 10, we understand that. Yeah. Okay, now so this is for conversion from string to primitive. Okay, converting to, okay, So if you have to do that, yes, what's the method? Public static. We have the static method in each of the class W. Okay, method has to return string. Name of the method will be toString. Parameter is okay the value. Here when I am saying PPP, it means the primitive type. Okay, so the class W will have the toString taking the corresponding primitive as a parameter. So conversion from primitive to a string is happening like this. Okay, fine. The integer and the long class. Additionally, have a few methods. Okay, so we have these additional methods in the integer and long class. Okay, so we have the public static methods. They would be returning a string. Okay, we have this method called toString being overloaded. Fine. So I'm just putting PPP, but it is int or a long then. Okay, because now we are talking about integer and long. Okay, so int or a long, give the value as well as the radix. So it will convert according to that radix into the string type. Okay, opposite of what we had seen earlier. Earlier we were having a string and getting it converted to the value. Fine, primitive or the binary value you can say. Okay, fine. Now we are converting from the primitive value into the corresponding kind of a string. So if you say 16, yes, it will be converted and given in a hexadecimal string. Okay, fine. So this option is always there, but we have special methods for the common radix values. Yeah, what are the common radix values? Two binary string. So you can just say two binary string and not give the radix. Okay, you don't need the radix, and you can also say two octal string or to hex string. Okay, so we have these methods additionally there in the byte and integer class. Fine, where we can convert to string, which is a octal string, binary string, or a hex string. Now you recollect what is the in the object class. I had mentioned this earlier. So I'll just remind you how the toString method of the object class was given. And we can see that two hex string was used. I have used it earlier, shown the usage earlier. In the object class, the toString method okay, fine. If you recollect, it was like this: public string toString. Okay, this is from the object class I'm putting. Okay, and what is the code in that? It says return and get class. So when it says get class, it's this dot get class dot get name plus @ plus, yeah, it says integer dot to hex string. And so that static method was and hash code. And this is how the toString method has been written in the object class. Okay, the code for toString in the object class is like this. Right? So you can understand use of toHexstring is already done in the okay. Okay, so these are some useful convenient methods. Okay, another one which is related to the float and the double type. Okay, there are some methods here which are related to the float and the double types. Okay, let's additional methods. Okay. Let's consider the float class first. Okay, it has this method, public method, static. Yeah, it's a public and static method. Returns int. Okay, and name of the method is float to int bits. Parameter is a float. Okay, another method is other way around. It returns a float. Name of the method is int bits to float. Parameter is the int. Okay, so what are these two methods? Because exactly similar line, we will have another couple of methods in the double class. Okay, name of the method here, the return type will be long, and instead of float, this will be double to long bits. Parameter here is a double, and same way, yes, this will be long, it's long bits to double, return type would be double. Okay, so what are these couple of methods which we have here? We see one of them takes input as a int, returns a float. Other one takes float as a parameter and returns a int. What are these two methods? You know, the size of both float and int is how much? 32 bits. They match in number of bits. Okay, fine. But we understand that when we are saying float, then the bits have to be treated according to the IEEE 754 standard, and then you know the value. It's a floating point value where the bits were divided into different parts. There was a sign bit, we had the exponential part, and we had the mantissa part. Okay, and then we would have to interpret the value, right? And whereas if I say int, just consider the bits with their positions according to the 2's complement. Okay, right? So you may have an int value, or maybe you have a float value, and someone wants to see the bit pattern for that given float. How can I show someone what is the bit pattern for a given float? If it's an int type, I have the 2 binary string. See, I want to see the bits in a int value. I can just see that by saying 2 binary string. Yeah, what is 2 binary string? Oh, giving me zeros and ones as a string. Right? So if I want to do a similar thing for a float, you know, converting from float to a int by doing a cast or any such thing would mean the value may remain same, but the bits are different. So it's not about changing the bits, keep the same bits and give it to me as a float type. Int bits to float. Okay, given a float, just keep the same bits, give me the equivalent int value. Okay, fine. This is like bits to be considered as it is. Don't change the bits. But what is the 32 bit as an int type? Okay, fine. So these are some methods which will be fine. Yeah, if you are working at the bit level, yes, these can be useful methods. Okay, fine. Now again, some more conversions are there. Lot of methods actually got added after Java 8 because we have that lambda expression thing. It's not that lambda expression thing basically. We haven't covered one of the topics, okay, which is related to the lambda expression. It is about the method reference. Okay. Okay. Now, this is one topic which I have not yet covered, and I'll be going to that a little later. But just to make this thing much better, okay, there are many static methods which have been added for that purpose. Okay, there are many such methods, static methods which have been added just so that you could be using method references at some places. Easily use method reference. It enables you to use method references. Okay, we know how that we can add two values by just saying plus operation, right? But instead of that, we still have a method which has been added called the add method or some method, something like that. Yeah, okay. Yeah, okay. A few more static methods. Okay, I'll just put it like this. In the from the method name, you should know in which classes this will appear. So we have this public static and method returns int. Name of the method is min, or rather than int, I'll just say ppp. Okay. Method name min. Parameters. Okay, that's a value 1. That's a value 2. So in the wrapper class W, you will find such method where W can be byte, short, integer, long, float, double. Okay, fine. For them, yes, find the minimum of two. Given two values, what is the minimum? Fine. Same way, just like the min, there is also a method called max. Okay, fine. There will be more methods. For example, I don't remember the exact method name, but method to add two values. Okay, method to multiply two values. You will have such methods. Okay, fine. So given two values, yes, how do I add two integer values? Fine. I think what we can do is even conversion to unsigned type. Yeah, we know we have that method called parse int. Yeah, we have the method called parse int. I think okay. I think what I'll do is we'll go to the API and API documentation. Have a look at some the class called integer and the class called float or double, one of those, so that we have a look at one integral type and one for the reference type. Okay, fine. So in the java.lang package, let's look at the classes, and yeah, we can have a look at the class called integer. Yeah, okay, fine. Look at the methods there and some of the static methods. We have some methods like this also, right? Bit count. How many bits are 1? Count of ones. Okay. Fine. Compare, unsigned. Yeah, comparing two integer values. Compare method. Fine. Returns int. It's that same compare method which we find in a comparator. Okay. Fine, but for primitives now. Fine. And compare unsigned means the two x and y, two things, will have to be considered as unsigned type. Fine. So range will be changed. Instead of minus 2 to the power of 31 and up to 2 to 31 minus 1, it is from 0 to 2 to the power of 32. Yeah, 2 to the power of 32 minus 1. Okay, 0 to, okay, fine. So compare unsigned. So those two values, the bits will be considered as unsigned int. Okay. This method is also there. We have this method called decode. That also takes a int and returns a string. Okay. Oh, we have a, takes a string and returns a int, right? This takes a string and returns a int. We had the parse method, but this is different from the parse method. Okay, this is different from the parse method. This decode is going to take a string which is used as a literal for that type. Okay, how do we write a integer literal? How do we write integer constants? Decimal, binary, octal, or hexadecimal, right? So you may have a string of that type and you want to convert it into a int. Okay, I'll put it on JShell and show it with the example so you'll understand, I think. Yeah. So we can, for example, we can say, okay, int a equals integer dot decode. Okay, and you could be saying 0x 0100. So hexadecimal 0100. You know, as a literal, if you had to write in your Java code anywhere as a literal, you would have used that kind of a thing, right? To indicate hexadecimal. Yeah. That's going to get converted. 100 as a hex, that means 256. Okay, fine. Oh, I can also write in binary. Let me just try this 0b. It's not working for 0b. They have not updated because you know that 0b is something which is from Java 7. It wasn't there earlier. It's only from Java 7 that literals can have 0b. Okay, so they have not updated the decode method, I should say. Right. Anyway, so it's not working for this, but yeah, you can say 0100. You start with a 0, that means it's an octal, right? And that's going to be converted to according to 100 being a octal value. Okay, so decode is for that purpose, right? Fine. This is different from parsing. Okay, fine. Instead of decode, if I had written parse, what do you think? If I use a parse int, 100, 0100 doesn't matter, it's 100. Fine. Fine. If I try a parse int and say 0x, yeah, what do you think? Parse int. What will parse int do? Huh? Oh, is x valid?
No.
No. Number format exception. But for decode it's valid because it's for, you know, the way you write a literal, right? Okay, I'm not sure. Actually, they should have done an updation so that it would even take the underscore. It doesn't. Sorry, I was trying parse it. Yeah. Let me try the decode. Does the decode work with this? Because this was in Java 7 where the underscores were allowed and 0b was allowed. Let me check this one. No, it's not decoding. And without underscore, yes, it would have done the decode. Okay, fine. So that's a decode method. Divide unsigned. So we have the divide as a method, right? Those operators are there, but yes, here it's there as a method, giving us a good option of using it as a method reference. So this can be, the method reference will be integer, double colon, and divide. Okay, divide unsigned. Yeah. Okay, we have the, yeah. Now these get methods, okay, which you are seeing here, get integer method, okay, they are different. They are not about converting from a string to an int, okay, but there are various things like the various properties of the JVM, the Java virtual machine. In the Java virtual machine itself, you can find out what is the version of JVM which is running currently. You have written a code, but in the code you might like to check what's the version where I'm being run. So a version, what's a major version? What's a minor version? So major version would be something like saying, oh, it is major version is 8, minor version is 0.01 or something like that. So you have methods which have properties. Okay, these are known as the properties of the JVM. So when JVM starts, yes, it would have these properties. So if there is a property which is a integer int type, giving the property name, you can know its value. So that's method available here. Okay, fine. I'm not sure, like major jdk.version, for example, that would be a string, but there will be some of the things. Okay, the actually equivalent things are available even in the string class, but there it won't be of type integer, but they would be of type string. As a string, you can obtain them. Okay, all the properties. I can just quickly show that here. Okay. Okay. There's actually a class called properties, and that's what is object of that is returned. So if I want, I can keep it as. Okay. See, for example, java.specification.version, that's a name. And the value is 19. Like this, there's so many of them, right? If I just say P, yeah, that's what it is. That's a whole lot of properties. Okay. And here also, it's not given us all of them. It's just put ... You can write a code to print all the values. There's a for loop which I can write basically. Okay, I'm not doing that here, but you can know os.name is Windows 11. That's a string type, but Java specification version, that's numeric type, right? I could use like this, so that integer dot get integer parameter Java dot specification dot version. Okay, and that's going to work and give me 19. Okay, it's basically fetching the system properties. If you know the name, right? If you know the name of the system property, yes, you can fetch that system property as an int type. If it's an int type, I can't do it for the something like that, right? sun.cpu.isa list. No, if I pass that, it's not int type, so that would be an error. So it's only for those. Fine. So those which have a int type, yes, you can use that. Okay. Hash code, highest 1 bit. What's the position of the highest 1 bit? What's the position of the lowest 1 bit? Okay, fine. Max min we had seen. Number of leading zeros, number of trailing zeros. Okay, fine. Parse int is not only about string, you can give any char sequence. Okay, it's not only for string now. Fine. Parse unsigned, parse as an unsigned value. Remainder. Reverse will reverse all the bits. Whereas reverse bytes, that's a useful method, reverse bytes. Okay, this can be useful because we know about there are two byte orderings, big endian or little endian. So converting from big endian to little endian, from little endian to big endian will require reverse bytes. Okay, so you may need that when you know that your the system, you may have a file which is created maybe in C language, right? And C language on a machine like yours, yes, it's going to use little endian, whereas Java uses big endian. So when you are fetching a value, fine, from a file, okay, which is in C language, you read the value as a, you'll get it as a int maybe, but then do a reverse bytes to get the correct value. Okay. Rotate left, yeah, these are just some methods, rotate methods, sum, fine, sum method, I was talking about that. So even something like sum is there. Okay, and two string, two binary string, two hex string, two octal string I was mentioning, the two string method is there, the two unsigned long. So if it is mentioned as unsigned long, right, it will return as a long because you know the range for int would be negative to positive, right? So for those things, right, which are 2 to the power of 31 and up to 2 to the power of 32 minus 1. Similarly on the fine, if it's in that case, yes, that can be obtained as a unsigned long. Then you'll need a long value to store that. Okay, value of method. Yeah, we have that value of, and we had seen this, right? Radix. Okay. Fine. So yeah, so that's about the wrapper classes, right? You can look at the methods in the API for others also, right? Character class also has a lot of methods which are related to the Unicode, basically fetching the Unicode properties for a character. Okay. Anyway, fine. So we'll continue tomorrow. Okay, and tomorrow we'll be looking at the enum type. We'll start with the enum.